back, 8th graders. We're in section 9.5, working on example 2. This time we're going to compare exponential functions, but there is something I need to show you first. And so I want you to put a pretty little cloud around this, okay? Let that stand out, because this is a new type of notation. They're going to use brackets, and then they're going to put, it looks like it's a point, but it's not. These are the x's of two different points, okay? And so this is going to be kind of a range of values, okay? When we're comparing nonlinear functions, because slope changes every time there's a curvature, the slope changes ever so slightly, but it is a change. What we're going to do is an average change, kind of an average rate of change. And of course, average rate of change is nothing more than slope. They're asking us, okay, if we pick 2 points, either off the graph or off the chart, could you give us the average rate of change for that? And we're going to need to use this formula right here. Boy, that's a blast from the past. We have not seen that formula since probably around Christmas or in January. y2 minus y1, there's our change in y, over x2 minus x1, there's our change in x. We're going to do change in y over change in x, but we need to know 2 points in order to do that. And they're going to give us this range. Either they'll tell us what year to what year. They will tell us in the problem what that particular range is, okay? Or what that interval is. So let me model example 2, and then you can try the quick check on your own, okay? All right, let's take a look. An investment analyst offers 2 different investment options for her customers. We're going to compare the investments by finding and interpreting the average rates of change. Okay, we are working with exponential. Now we know we're working with exponential because we've checked it. The graph looks like it's doing a little bit of a hook there. In investment B, investment A, it wouldn't take much for you to take your little calculator out and do $13.38 divided by 10. And so I've got 1.338, and then do 17.91 divided by 13.38. Pretty close, the same thing. 23.97 or 97, that's right, divided by 17.91. Okay, so it's all pretty close to being about 1.338, about $1.34 or so. So it looks like it's pretty close to being exponential in its growth, because I see the evidence of there being a common ratio. Let me take this off because we won't need this. Okay, what we want to do is we want to check the average rate of change, and they told us what the interval is right here. This is key. They want us to use this point 0, 10 and up to year 20 right here. So what are we going to do with the rest of these points? Here, 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 and here. Nothing. We're going to ignore them. They are not part of this problem. We don't need to worry about those points. They're not essential. They told us what interval to check, 0 to 20, and that's what we're going to do. If I did it with the brackets, it would look like this. So this would mean find the first point where x is 0. Here's your second point where x is 20. And here they are. Here and here. Okay. So let's take a look. We're going to do change in y. So let's do 3207 minus 10 over the change in x, which is 20 minus 0. So I've got 2207 divided by 20. Get your calculator out. You're going to need it. 22.07 divided by 20. And I've got right at the decimal 1.1035. Okay? Now, don't walk away from that. You crunched a number. That's great. But what does it mean? And so you want to use, if you did change in Y over change in X, that would be dollars over year, dollar per year. So really what this is right here is $1.10 per year. That's really what it is. So we don't need that 3.5, we'll just kind of strike it. So that investment is going to gain for the customer every year $1.10. That may not sound like a lot to you, but that's money that you're not earning. So that's the investment's gaining that for you. Plus, we're not working with a pretty high dollar amount either. All right, let's go to the graph. Now, you have to take the graph and find points off of it. So the first one says, okay, when X is 0, Y is 10. So there's our first point. When X is 20, now we're going to have to do a little bit of estimating because that's where it is. So it looks like it's slightly above 25 in the book and on my graph. So let's estimate that to be about 26. Some people might say, hey, it looks like 27 to me. Others might say it's 26. It doesn't really matter, okay? It's close enough. So we're going to do change in Y over the change in X. So that's 16 over 20, which is the decimal 0.8. Now, if we look at it, it's going to be change in Y, dollars over change in X, dollars per year. So what this means is this investment only gets 80 cents each year of an increase. So if you are an investment counselor, an analyst, and you had customers sitting in front of you and they were asking you, should I choose investment A, should I choose investment B? You would have to tell them that they should choose investment A. And so that's how I would sum it up. Investment A is the better option. And you can see from the money, or from the money standpoint, why it is. It makes more money for the customer. Okay? The quick check is yours. So there you go. This time they changed the interval from 10. They want you to start with when X is 10. What's that point when X is 25? That's not the point 10, 25. These are two different points. This is your first point where X is 10. This is your second point where X is 25. Find the average rate of change, and from that interval, what would be the better investment? Okay? Awesome. Okay, try that on your own, and you may have to look in your book on page 661, because I didn't draw the graph showing year 25 on my graph, but it's in the book. So you may want to check that. All right, thanks for listening.